All right, guys, so we've worked with polynomials before. What we're going to be doing now is finding the sum, difference, product, and quotient of functions. So our four main operations, we're going to be doing them with any function. So similar to polynomial stuff. So here's what addition looks like. And in this first little section here, you're going to see some new notation. So very important to remember. So normally, you guys are used to seeing like f of x and g of x. So we're going to start with two functions. Remember, this is just function notation. The x in the parentheses refers to the variable that we're using, and then the f and g just gives a name to the function that we're talking about. So here is how we write addition. We will have f plus g, and then we'll still have the x in parentheses. So whenever you see that notation, you know you're going to be adding those two functions together. So what it really is you just take your function f and then add it to your function g. And just kind of combine up like terms. Okay, so this notation means you're adding the two functions together. This notation means you are subtracting one function from another, so be careful with subtraction because order does matter. It means you're taking f of x first and then subtracting g of x, not the other way around. Multiplication, you will see f times g right inside the parentheses here, and then x is still your variable. So that is f of x times g of x. And then finally division, if you see f over g, that one represents division. So you would take the entire function f of x and divide it by the entire function g of x. This one has a very, very important domain restriction. You cannot have a denominator of 0. So with this one, whatever would make your denominator 0 needs to get excluded from the domain. Okay, so that's what we mentioned down here. If there are any restrictions in the domain and range, that'll only happen if you're dividing by 0. All right, so this will give you something that we call a domain restriction. Okay, so for this first example, we've got two different functions. Here's our function f of x. Here's our function g of x. So this first one says f plus g of x. So remember, that's the same as this. So I'm going to write that out first. So this is the same as f of x plus g of x. So all I'm going to do is I'm going to take my function f of x, right there, and then plus, and then take my function g of x. And adding literally means you're just going to combine up the like terms. So I've got, for my x squareds, I have a 3x squared plus 2x squared. So I can combine up those terms and I get 5x squared. I get 7x plus a negative x, so 7x minus x, and that leaves me with 6x. I don't have a constant here, so technically like 0 plus negative 1. So that leaves me with negative 1. So that is my new function that I got from addition. Let's see what I get from subtraction. So f minus g, again, I can just copy this down first. So it's my function f of x minus my function g of x. So really similar to what I did up above, just subtraction instead of addition. So copy down my function, but then minus. So with the subtraction, it's super important to make sure you have parentheses because you're subtracting this whole function, which means you're subtracting 2x squared, you're subtracting negative x, you're subtracting negative 1. So let's be super careful with that. So 3x squared minus 2x squared. That's going to leave you with just a single x squared. 7x minus negative x. So that's really like 7x plus x. So that would be an 8x. And then I technically have a 0 over here. 0 minus negative 1. So that's like plus 1. Okay, so that's what addition and subtraction looks like. Pretty straightforward. You're basically just combining like terms. Let's flip and look at the multiplication and division examples. So f times g, remember that's the same as f of x times g of x. So I'm still just going to keep my functions in parentheses. And then times x minus 4. So this is like foiling, basically, like super foiling. So I start with a 3x squared. You multiply the 3x squared first to the x. So 3x squared times x gives me 3x cubed. Then the 3x squared times the negative 4. So that gives me negative 12x squared. Then I move to my next term here. I move to the negative 2x. Negative 2x times x gives me negative 2x squared. Negative 2x times negative 4 gives me positive 8x. Then finally I move to the 1. 1 times x is just x, and 1 times negative 4 would be negative 4. So for my final answer, I'm going to combine up my like terms. So I just have the 1x cubed. I combine these two for my x squared, so that would be a negative 14x squared. Combine these two, I get 9x, and then that minus 4 is my only constant. So that is your new polynomial. Still no restrictions in the domain and range because there's no denominator. Denominators are the only issue with domain and range. Okay, now f divided by g, that looks like it should be like sort of crazy complicated, but all we're going to do is literally just put one of them in the numerator and one of them in the denominator and write it out like a ratio. Okay, so this is the same as f of x divided by g of x. I'm just going to put f of x in the numerator over g of x in the denominator. And remember, g of x cannot equal 0, so let's do a little side work for that. So x minus 4 cannot equal 0. So to see what x can't be, I'm going to add 4 to both sides. So this is my domain restriction. So this function, as long as I don't try to plug in a 4, because if you plug in a 4, you'd have 4 minus 4, which would be 0 in the denominator. I can have 0 in the numerator. That's something that you guys get mixed up with. You can definitely have 0 in the numerator, but you can't have 0 in the denominator.